Hello there, here's another video to update you on a blog entry I've made today, and it's called 1 Mile Level Line. But before we get into that, I want to take a minute to do what I've seen some other people doing on their channels, and that is to discuss how to subscribe. And I'm up to 280 subscribers now, which is great. I appreciate all of you subscribing. What I've seen folks do on some of their videos that they're making is to talk about subscribing and making sure that you click this this little bell, which then brings up this little box which you will check and save it, and that way you'll get notifications for when I post new videos. So make sure you do that. I use my iPhone a lot, and I don't see a way of doing that on the iPhone, but you might just have to do that on a laptop first. All right, so I just wanted to make that point, and again, thanks for all of you subscribing, and please share my channel if you think what I'm doing here is of value, and you know people that are interested in these topics that I'm posting about. Lately, I've been doing some level lake tests. I have 2 videos on that. I let John McIntyre know what I think of his tourism, mountain tourism and scenic photography. That was my second video on him. The first one was I was pretty enthusiastic about the efforts he was going through, but you can watch those videos to find out what I have to say there. Here's a video I did discussing Mark Sargent interviewing another plane surveyor. This is the second one, and this is in his series Subject Matter Experts, where he's getting people on his show that are supposed to be experts in their field, and then he brings on these plane surveyors who've never done any type of work involving the Earth's curvature, and asking them questions that they can't answer, and then the conclusion is, well, the Earth must be flat. Okay. Yeah, keep going with that strategy. I'm sure it's working well for you. This video here, show us the measurements, is where I go through the video that's called Flat Earth Proof 3 Land Ho. And I go through that step by step. And that's my answer to that video. Take a look. Here's another level lake video. Here are some videos on observing New York City from Washington Rock, also from the other side, from Fire Island Lighthouse. Here's a video on observing lighthouses on the Delaware Bay across the water. I did these videos on the water because a lot of people kept saying that that's where you really should be making these measurements. And I'll leave the rest for you to find here on my channel, and I'll close that and continue with this particular video. So this is called 1 Mile Level Line, and you're seeing some screenshots from, if you've seen my very first video, I had this test I did in that video, measurements of curvature in 1 mile, and this is on a New Jersey highway, Route 206, and it's between milepost 27 and 28. And I'm going to be talking about that test here, and I'm going to talk about some recent trips that I've made back to that line. So let me just talk about this a little bit. This was my very first video, and it's going on a year ago. Or no, I posted this video in, I guess, February. Okay, whatever. Anyway, it's packed with a lot of information. I've since pulled it down from my channel only because there's a few reasons. One, I definitely was coming across in a mocking tone. I don't want to do that anymore. I really don't feel that way. I'm actually really interested in presenting the measurements that I'm making, and hopefully it's coming across in a more helpful way for those that are interested to really look at these things. There's no need to mock anybody, and I'm just trying not to be that way about it. So I yanked this down. It has been mirrored. It's out there. and that's fine. Um, what else? So yeah, this was me being very naive, thinking, well, I'll just bring geodesy to the table and that'll straighten out all this flat Earth business. And things don't work that way. So, and that's fine. Um, I get it. Anyway, in this video, I go over this 1 mile test, and I provide my field notes. Basically, again, there was not much planning to this. I thought, hey, if I go find a stretch of highway that's nice and flat, and I set up my instrument and measure the zenith angles from each end of the line, and I just chose 2 mileposts to show me where a mile was. It will obviously indicate a tilt between the 2 vertical plumb lines at each end of the line, and that's what it did. And I just measured 6 sets of angles. I've seen some commentary or some criticism of that wasn't enough and so forth. Well, you're going to find out what I did in this video. I go through a lot to replicate this test. So basically there were 6 sets of near real-time reciprocal zenith angles, and here I tabulate those results, and basically it revealed approximately a minute on that line. And so I wanted to clarify this. I'll read this to you. The raw measurements, uncorrected for deflection of the vertical, are referenced to the geoid. These measurements reveal the tilt that exists between the vertical plumb directions at the ends of the lines. In other words, if this weren't the case, the vertical plumb directions would be parallel, and they would be parallel everywhere. And therefore, if you measure these zenith angles at each end of the line, they will sum to 180 degrees, but they never do. That's really true, and I encourage anybody to try this for themselves, or if anybody has found otherwise, please get a hold of me. I'd like to see your data. You can come here to the blog. That's the best thing to do, and I've put in some hyperlinks to some of these topics and some of these terms, and you can go here and explore these topics yourself, so you can have a better understanding of what is being measured, and how this all works. So this was an approximate test. I'm making the point here that if need be, for various specific applications that require very precise determinations of the curvature and the tilt, high precision measurement procedures can be applied to account for these differences at very exacting positional tolerances. I've made the point in other videos, we are dealing with measurement, and measurement is subjective. It's, you have to repeat the measurements in order to quantify or qualify the quality of those measurements. So here I'm giving you one example of very high precision being applied is the construction of the LIGO facility. And I've included this paper, Precision Alignment of the LIGO 4 kilometer long arms using dual frequency differential GPS. Take a look at that paper. It discusses how they constructed these long tubes to be straight. They could not follow the curvature of the earth. They had to be straight. And if they did not apply the techniques and methods and procedures that they did, these tubes would generally follow the earth's curvature just like any railroad does, any highway does. And a lot of times on Facebook in these flat earth groups, you see these memes always posted about how no one takes curvature into account when they're constructing a railroad. Well, no, duh, because you don't have to, because it's going to follow the Earth's curvature without you doing anything. And the cool thing about this this construction project is that they had to do quite the opposite. They had to do the absolute reverse, and that is not allow these tubes to follow the Earth's curvature. They had to build them to be straight. So, well, why do they do that? Well, they think they're going to be able to detect gravity, and that's not the topic of this video, but I'll just say this, that the closest LIGO will ever come to detecting gravity was during the construction when the tubes were built straight rather than following the natural curved level path linear structures such as pipelines, highways, and railroads normally follow. So that's all I have to say about LIGO, but I did find this very cool paper that the tubes were built straight, and they're actually talking about the possibility of building them longer. And if you look at this little presentation, they're discussing the idea of building them to be 40 kilometers long, and they go through all of the Earth curvature calculations, which is great. It's good for my video. So I leave that for you to go take a look at. Very interesting. I had no idea they were talking about doing anything like that. Well, you know, it's to get more funding when they do these things. Anyway, moving on. Back to Route 206 in New Jersey. I did this last year, and I did it again this year. It's November of 2015 is when I went out there the first time. And I did it again in 2016, this month. And I did some high precision GNSS observations, collecting multi-constellation, multi-frequency data. And I post-processed the vectors between points 27 and 28. And I was able to compute the geodetic latitude and longitude and ellipsoid heights using these NGS cores stations. And I used, where are you? They all disappeared. Here's one. Yeah, I think this one. Come on now. Yeah, I used that one, NJTW, and NJGC. You can go here, you can download the coordinates, you can get the data, the actual data right off of the internet. And that's what I did here. I hyperlinked to both of these cores. So once I had all of that data, I had my data that I collected on the mileposts, and then the data from these two cores. I processed all those vectors. They are repeated so that you have you have repetition. You need to repeat your measurements. You can't just measure something once. You got to measure it at least twice, preferably more, for the highest precision. And I think I'll be making a video at some point about accuracy, precision, and positional uncertainty. So I'll be doing that. So I post all the vector information here, and then I tabulate the actual computed geodetic latitude, longitude, and ellipsoid height of both points, 27 and 28, and then the projected mapping coordinates projected from the curved surface onto a flat mapping plane. It's known as the state plane coordinate system. I've talked about that in other videos, and it's probably due its own specific video. Here I provide the datum and my units, US survey feet. Again, here we have more hyperlinks. I think you should click on these. What does it mean to be adjusted? We use least squares adjustment to solve for the resulting coordinates. When we have repeated observations, you want to adjust each observation appropriately to come up with the correct position. And here's state plane coordinates. And again, I've linked to the pictures because pictures are nice, but you can also hit all and go through and do some reading there. So it's all good. Okay, moving on. So I came back a year later to repeat the test. Now this time I decided, because I did see some comments that, hey, I didn't take elevation into consideration. Well, those people that are making that comment are actually wrong. you're flat out wrong. The sum of the zenith angles at each end of the line, no matter what the terrain, the sum of those should equal 180 degrees if the vertical plumb directions are parallel. It doesn't matter what the elevations are. But because people are talking about that I left out the elevations, I went back, and what I did this time was established a level line of sight between the 2 points. And the way I did that is I just picked an elevation 5930, which was kind of roughly, good enough between the 2 points that I could easily measure up from one elevation at point 27. It's an elevation of 5379. I measured up 5.51 feet. That makes a sight line of 5930. And at the other end of the line at point 28, which has a slightly higher elevation, again, I set the target at the same elevation by measuring up 4.78. So basically, I created a level line. Here's the target set at milepost 27, and that target is at elevation 5930. And then I set the theodolite up at milepost 28, and I measured up 4.78 feet, which means that the telescope is at elevation 5930. So the target and the theodolite are at the same elevation. And when I set my scope to be horizontal, I looked through, and what did I see? I noticed that the horizontal crosshair is over the target. It should be on the target, right? It should be on the target, but it's over the target. And I state that here. And then I went on to measure 6 independent sets of 4 sets of zenith angles. And I'll show you how that goes. And I'm going to show you a video of what I was doing there. So then I did this repeatedly from one end of the line to the other, and I did that 6 times. So I spent the day there. Again, now the theodolite is set at point 27, and the target is set at 28. And again, between the two of them, they are on a line that is at elevation 5930. Looking back the other way, what do I see? The same thing. My crosshair is over the target. Down below, I'm going to tabulate and show you what's actually happening. So here again, I just make the same statement. It's just in reverse. And so here I also indicate that I recorded the time at the start and the end of each independent set of zenith angles, and the weather. I just snapshot this on my phone. So I had the weather, the temperature, the humidity, and the pressure at the beginning and end. Here I'm just indicating the billboard that I saw along Route 206 right there where I was doing this test. They must be getting desperate if they're looking to sign up surveyors now. I'm wondering what this is about. This billboard I've been seeing all over the place. Maybe you have too. So, yeah, no thank you. Anyway, here we have a tabulation of all the sets A, B, C, D, E, and F, with the start time and the end time, and each one, its mean, standard deviation, and standard error of the mean. And then here we have a tabulation of each reciprocal set. So set A was from 10:05 to 10:28. Here's the zenith angle from 27 to 28, and the zenith angle back from 28 to 27, and the delta. So you could see, they're all in good agreement. And then I just computed the mean of all 6 sets, and there's the end result is a minute and rounding off to 10 seconds, let's say. Which, what did I have the first time? A minute and 11 seconds. I basically went out here and measured the crap out of this line for a few hours, and I'm getting very consistent results with the first time. here I am just pretty much at the conclusion of this, where I'm showing you from 27 to 28, and the elevations are the same. These are level. Delta elevation is 0. There's my observed zenith angle, just rounded off to the nearest second now. And here we have the reciprocal sum is 1 minute 10 seconds. Now if you compute the arc on a spheroid using this formula, using the cosine and the sine of the latitude and the longitude, you get a computation of 50 seconds over this between these two geodetic positions. This is an approximation, but we have very good agreement here. And then I include the 8 inches per mile formula to compute the drop of the curve according to that approximation. And I also include the trigonometric calculation using the actual distance here. Now, isn't this interesting that between 2 mileposts you should have 5,280 feet, but I guess they're not very precise in the placement of these mileposts, because I measured 5,047.29 feet consistently. And anyway, so that's interesting to find out that it's not actually 1 mile between the 2 mileposts, but nevertheless that's the distance I'm using in my calculation. So the 5,047.29 feet. Now you look at the sketch and you start to understand why do we see the crosshair over top of the target from both ends of the line. Why is that? Oops, where's the other one? Here, this one. There's the target right there. And this is the zenith angle is set to 90 degrees. In other words, that's set horizontal. So you look at the sketch here, and that's because the horizontal plane is perpendicular to your vertical direction at this end. So you're going to have this situation, and there's your drop of the curve. And then if I extend this line out, you're going to have the same situation. Horizontal plane is perpendicular to the vertical plumb line. It can't get any plainer than that. Okay, I think that's it. There's nothing really more to say, and more videos are on the way. I've got more to say, and I've got a few more experiments in progress, and I'll be making some videos on those. So I'll end here saying the same thing I've said in other videos. My comments are turned off. It's too easy to just lob in stupid comments. I'm looking forward to connecting with people now, and you can certainly email me or send me a message through YouTube, and let's talk. And that's it. I'll see you again on YouTube later.
Lights basically consist of a series of mutually perpendicular axes. The vertical axis, which passes through the center of the horizontal circle, the trunnion axis, which passes through the center of the vertical circle, and the line of collimation, or line of sight, which passes along the center of the telescope through the center of the crosshairs on the diaphragm. Before it can be used to measure angles, the theodolite must be carefully centered and leveled so that its vertical axis passes vertically through the station, its horizontal circle lies in a horizontal plane, and its vertical circle lies in a vertical plane.